This video is about simplest radical form. You may remember from previous math classes that a radical is this funny looking sign right here, and this little character is saying radical, like totally, as he goes into the radical sign. A radical sign tells us that we're taking a square root or a cube root. There might be a 3 in here for a cube root, or a fourth root, etc. Whatever number goes inside of this little groove is called the index of the radical. And in this section, we're going to be working with square roots. Square roots are the most common kind of radical, and in fact, we write the radical sign without any index at all when we mean square root. To remind you of the definition of square root, what we mean by the square root of a number is that it's the number you would have to multiply by itself to get the original number. So in other words, the square root of x times the square root of x gets us back x itself. So mathematicians are picky about the way that we write our answers if we have answers containing radicals. We have two rules for putting numbers in simplest radical form. The first rule is no unsolved roots. Well, what do we mean by that? What we mean is that if we have a number inside of a radical form, that we could make that into a smaller number and put instead a number outside of the radical. That's better and simpler. So the reason I put a number 8 under this square root sign is that we can express 8 as 2 times 2 times 2. And notice that this pair of 2's is really a number squared. 2 times 2 is 2 squared. So what we can do here is we can take this square number outside of the radical and express it as just plain 2. So the way we would write this in simplest radical form would be taking out this square number. We would write this as 2 times the square root of 2. Now, one memory aid for doing this is something that I learned from another teacher. We imagine that the radical sign is a scary house. So suppose we have a bunch of people trapped inside the scary house. 2, 2, and 2. And the witch that controls the scary house has a rule that if you want to escape from the scary house, you have to come out with one other person who's just like you. And when the two of you come out together, one of you is going to disappear. So that's the risk you take if you want to escape the scary house. The two 2's are going to try to come out together, but poof, one of them's going to disappear, and you're left with only one 2 who escaped and one lonely 2 left inside the scary house with no partner, so that one can never escape. And we have, in simplest radical form, 2 times the square root of 2. Okay, the second picky rule that mathematicians have is we don't like having radicals in a denominator. The denominator is the number on the bottom of a fraction. So suppose that our answer came out to be 1 over the square root of 3. A mathematician would say, gross, that's ugly. I don't like square roots in the denominator. So in order to simplify an expression like that, we would multiply the fraction by the number 1, but we would express the number 1 as the square root of 3 over itself. Any number over itself is simply 1, so we're allowed to multiply our answer by 1, of course. But when we multiply these two fractions, 1 times the square root of 3 gives the square root of 3 in the numerator. The square root of 3 times the square root of 3 gives us back simply 3. And now we've expressed this ugly number in simplest radical form. So these are two examples of answers that are in simplest radical form. This would be a non-example. And the square root of 8 would be another non-example. Okay, let's do a little bit trickier example together. We want to simplify the square root of 72. Now 72 is not a perfect square, so we can't simply take the square root straight up. But instead, we have to find out if we can express 72 in terms of some other numbers that might be able to come out of the scary house in pairs. And the way we can do that is to make a factor tree of 72. Notice that 72 is 36 times 2. And look, in our first step, we've found a perfect square. 36 is a perfect square. So we can express this number as 36 times 2, or 36 is 6 times 6. So 6 times 6 times 2. Now we have a pair of numbers that can come out of the scary house together and turn into just 1 6. Inside is left our lonely little 2, and that is our answer in simplest radical form. You try this one. Simplify the square root of 75. Let's do another example. This example uses another rule that we might not have remembered from previous math classes. If we have a radical, remember that the index here is 2. We don't have to write it, but it's really a 2. If we have two radicals with the same index, we can combine these two radicals into one big radical with the numbers inside multiplied together, since this is a multiplication sign. Now we have 5 times 35. Okay, 35 is a number that is not broken down into prime factors. So let's write 35. Let's make a factor tree. 35 is 5 times 7, and those are prime factors. So we're going to rewrite the expression under the radical sign as 5 times 35, which is the same as 5 times 5 times 7. Look, we have now a pair of numbers that can come out together and turn into just one, number 5, with a 7 left inside. Since the 7 is prime, we can know for sure that there's no way to further simplify this expression. You try this one. Simplify 4 times the square root of 28. Let's do one more example. We're asked to simplify this expression, and the bad thing about this is that we have a radical in the denominator. So remember our trick for simplifying an expression that has a radical in the denominator. We can multiply any number we want by 1, and that number is not going to change, but the form of it is going to change. So multiplying by 1 is the same as multiplying by the square root of 2 over itself. When we multiply straight across the top, we get 24 times the square root of 2. Multiplying straight across the bottom, we have 3 times the square root of 2 times another square root of 2. So that's going to turn into 3 times just plain 2. And in the last step, we can say 24 times the square root of 2 over 6. Just kidding, that's not the last step, because look, we have 24 and 6. 24 is divisible by 6, so this can turn into a 4. So we have, in the final step, 4 times the square root of 2. You try simplifying this one. And just a hint for you, if we have a fraction inside of a radical sign, we can break it up into a fraction with the radical on one radical on top and one radical on the bottom. For further practice, see page 288 of your text, numbers 1 to 15 odd.